Hello, Barracuda friends. My name is Jorge Pablo Garcia. I would like to mention to you that I'm in charge of pyroprocess and energy in CEMEX company dedicated to cement production. And it's a pleasure to be here with you, at least virtually, and also sharing and giving the thank you to the team of Barracuda with Peter Blazer that has been supporting us in this journey. Our target for the 2050 is the reduction and elimination of the emissions of CO2 and bring to a net zero from all our company's facilities. As part of this journey, CEMEX has been started to implement a new ways for digitalization with new designs. As example today, we are going to explain the topic of Rudniki digital design twin that we have been working with our company together with Barracuda software, where we are going to be using and controlling some parameters from our operation side in order to develop a new technology. What is the purpose of that? Very simple. So we are going to be connected in real time to the control room operation in order to transfer the reference in a virtual way and also evaluate simulations with new technology. All the simulations will be receiving in real time the information for the plant side, generating new virtual parameters. All these parameters could be compared at the end of the simulation with the real situation of the plant side. What is the advantage and purpose of that? The advantage and purpose of that is like our operations will have the opportunity to validate a new project, a new design in one of our plant sites. This will give them the advantage to knowledge and also the advantage to know how could be the operation, the advantage to know how the emissions related to the CO2 will be in the plant site if they install a new design with this type of technology. So the advantage of this is to develop to the next level. The next level will bring all the virtual designs before to be built and make decisions in the right time before to any capex investment. That will give you the opportunity to the plant sites to decide what is the better or what is the best design to their installation according to the specific circumstances. In this journey today, we are going to be discussing the topic of Rudniki plant site, where we are going to be simulating one of the gasifier technology. So for this journey, we are also happy to share the reference for three persons. One, Piotr Bebelowski, our plant director manager from Rudniki plant site in Poland, also is going to be sharing the topic of how it's going to be doing for the CFD simulation with our colleague Carlos Eduardo Marquez in our installations in Monterrey, Mexico. And we also consider the participation of Jorge Moncada that is going to be connected from Switzerland in order to review all the parametrization and validate the control and connectivity to all the parameters from the software and also from the control room. So the big challenge is like all the simulation will perform in real time. That is part of this journey. So then I would like to share the reference.
My name is Piotr Bebelowski and I have been the director of the Rudniki plant located in Poland for over 17 years. The plant has been part of CEMEX since 2005. As Rudniki is located in the northern part of Silesia region, Silesia province, the most industrialized area of Poland, our process has been based on using the waste raw materials from other industries for over 15 years. Now, this allows us to maintain a high proportion of waste raw materials used for cement production, 46% amongst in this current figure. The plant was modernized in 1999 to 2001 as first stage. On that time, mainly focusing on the dusting, dusting installation, raw materials preparation, including raw milk modernization at that time, cement finish mills, and storage, shipping, packing, palletizing system. A very important direction that we have been pursuing in Rudniki since 2007 and very interesting is that of substituting heat from coal with that from alternative fuel. Following the kiln modernization in 2019, it was the second stage of modernization where and when we modernized the head of the plant, the kiln line. We get to manage to achieve 92% of heat substitution with waste-derived fuel after 2 years of gaining experience and optimized areas on the old installation, the old kiln. We could achieve only maximum 52% of substitution, having at disposal only main burner. Plant operates now on 5-stage heater towers with a modern calciner with very high retention time, 7 seconds, which has significantly improved the heat exchange condition, reducing heat consumption by 30% versus before the modernization. Alternative fuel take into account the biomass content in Poland, in our case, is about 35%, and optimized heat consumption to make clinker have allowed us 18% reduction of CO2 emission, carbon footprint per ton of clinker. It is worth emphasizing that this high alternative fuel usage rate allow us to avoid burning about 50,000 tons of coal each year. Another area of our intensive experience and work is currently the reduction of the clinker factor, especially because we are located very, as I mentioned before, industrialized area of Poland with very broad access to different waste raw material from other industry. In which, due to technology and location, we have specialized for years with usage of this material. All of these efforts I tried to enumerate before are included as part of the decarbonization roadmap of CEMEX. CEMEX is implementing the most important program called Future in Action, and this roadmap is included in this program. We see great opportunity for sure to use digital technology, which could be based on our processes, operational quality data available in almost real time through our PI system. I see special space for optimizing the combustion condition for LDF in main burner, so that we can approach to almost 100% of the level of heat substitution with alternative fuel. Is for us right now one of the main challenges. Another interesting area of analysis is the further reduction of the heat consumption or minimizing of the negative impact of the circulation of volatile substances in the kiln system. Another slightly more distant area that is extremely important to us is the use of the digital technology simulation to optimize efficiency or carbon capture processes. This is right now to tell the topic in which we are keenly interested. Thank you very much for your attention.
Hello everyone, my name is Carlos Marquez. I work at CEMEX, a global building materials company that provides high-quality products and reliable services. Using simulation tools like Barracuda Virtual Reactor, together with the support of CPRP software team, we can analyze our production processes to make them more efficient while reducing our carbon footprint around the world. At CEMEX, with the support of Barracuda Virtual Reactor, we are building a better future.
Hi, this is Jorge Mucada, and I'm working as the responsible for the process automations and control in CEMEX, located in Switzerland. And I would like to let you know or to inform you about how are we connecting this solution. The connection between these equipments happens, first of all, by observing the plant. When we have the plant, we have a central control room where our operators are located, and from that place, we are able to control all the process cement line. What is interesting from this point is that we are able to collect all the data from each process, sensor, and instrument that is measuring every part of the line, preheater, kiln, etc. All this information is collected in real time in the server located on premises. What we are able to do with this information is to send it to the Barracuda software. The Barracuda software is capable to read this information, process it, and then after that is sending the results back to the plant. What we are able to do then is take this information and be able to display it in the screens in real time. So we are able to read continuously the new information that we are collecting from Barracuda and displaying in our cement process queue.